Here we have a wire with 0.14 amps of current running through it. The wire comes along, it goes into a loop structure with 600 loops and then keeps on going. What we have over here is a proton. What the proton is going to do is the proton is going to fly across the coils, and when it is right in the middle of the coils, the current's going to be turned on, and we're going to find out how much force is on the proton when it's in the middle of the loops because of the loop's magnetic field. So first we're going to start by just finding out the magnetic field strength that is possible because of the loops. And to calculate the magnetic field from a loop is n mu naught I over 2r. So I got n is the number of loops of 600 loops. I've got the mu naught, which is 4 pi to the negative 7, the constant. We've got the current of 0.14, and then we've got twice the radius, which would just be the 16 centimeters. So I can calculate the magnetic field strength. So if I calculate that, I get a magnetic field of approximately 6.6 times 10 to the negative 4 Teslas right in the middle of the coil. And then using my right-hand rule, I can figure out that the magnetic field would be coming out at that location, so it would be a dot, which I will need later on for the direction of my force on my proton. So now I can calculate how much force is on my proton. Now, when I do that, of course, the magnetic force and charge in a magnetic field is QVB sine theta. We can make sine theta equal to 1 because everything's going to be nice and perpendicular. I have the charge of the proton. I know that. I've got the velocity of the proton of the 7.5 to the 6. I will use the magnetic field that I found for my B value, and then I can calculate how much force is on my proton. So using QVB and calculating the force, I get a force of about 7.9 times 10 to the negative 16 newtons. Now we're going to look at the direction of the force. Now the proton is moving towards the right, so the force can't be sideways. The magnetic field is going in and out directions, so the force can't be that way. So as a result, the force has to go up or down. And using my right-hand rule number 2, I can find out that the force is going to be going down at that location. So it would be 7.9 times 10 to the negative 16 newtons, and the force would be going down.